obviously removing legacy will involve some refactoring. That means that we should be sure about what we are doing. If we break stuff, there will be consequences. This is also a product which is an online product. It makes money by being online. So every time it's down or broken, a loss of money occurs. Okay, so actively developed. It's an actively developed product, meaning this is a product that's been developed by a Scrum team using standard Scrum methodology and with a 2-week release cycle. And this is where really our story starts. The client said, OK, we have ambitious plans. We want to change some architectural features of the product and make it future-proof, which kind of relates, get rid of the legacy. And to make it fun, we want it to be a waterfall project. And to make it even more fun, while you're doing your stuff, the original team must continue work on it in a standard way and develop new features in a normal tempo. And at the end of the project, all of these features should be available on this new, better version. So it was fun. So obviously, we are talking about legacy. So our legacy situation was mainly legacy framework. There are some other legacy technologies. But in this context, this is a framework which we decided as a company that we will make it end of life. So therefore, it's a legacy. It worked, but it made stuff harder, especially testing the data layer. It was, it had singletons. It had a lot of things that seemed like a good idea at the time it was written. We also had already some Symfony stuff there. Dependency injection container. We had router. And obviously, for a legacy system, we had very low test coverage, which is, if there was tests, there were mostly functional tests. Some unit tests, but really not that much. OK, so our first idea was, the logical idea. So what we want to achieve is have this. We are having a 2-team situation. One which is developing in a Scrum way, adding new features, and the other which is doing the refactoring work and adding these new features which are part of this ambitious plan. So what we want to have is get rid of all the legacy and have a pure Symfony application, which will, in effect, has good architecture, and port all the features that will be developed during this time. So yeah, obviously, refactoring was the key element. So we considered 2 approaches. First is we fork, and then 2 teams work more or less independently, and then in the end, we merge. This seemed like a really clean way, because then each team can focus on their own stuff, and then there will be merge. And the other way, but this just introduced too much risk of the merge, horror. So the idea was you have like this red development and blue development. In the end, you merge both and get purple. And what we end up doing is make small iteration, and after each iteration merge, and then make this a bit more purple with each iteration. So this is what we end up choosing, and this was fun. So the idea was get all of the legacy and do refactoring like this. But yeah, this wasn't realistic. We figured out that there is too much unknown in a system which is legacy. That's why it's legacy. So, and since we were having this other team was working in a waterfall fashion, that means that we have really limited amount of surprises that we could afford. So in order to do this, we said, OK, what's the next best thing? The first would be remove all the legacy and have like a beautiful, perfect architecture. So but what's the next best thing? Remove half of the legacy. It doesn't make sense. So what we want to figure out to do, and this actually proved to be the right way to do it, is refactor the system just to the point where there is no need that any new commit really adds any more legacy. So if you change an existing feature, you can do it in a way that doesn't add a legacy. If you add new feature, that's easier, but still you can do it in a way that does not add legacy. So in the end, as a fact, there would be still legacy left in the system, but it will get diminished over time, if we follow the Boy Scout rule, of course. And of course, yeah, we add all those new features in it. OK, so there were like 2 major challenges. First is that we had to find a way to stop legacy creation, because if if the team that's developing new features, do it in a standard mode of work, they will be adding new legacy with each feature. New class would be new data entity would still use legacy data model and active record and so on. So we didn't want to do that. And the other was, okay, you have two teams and working in different methodologies and how to synchronize them. So these are the 2 points of the talk that I am giving right now. So first is to stop legacy. Okay, in order to improve anything, you have to be able to measure it, because in order to stop adding legacy, you need to find a way to deterministically know that you are not adding any more legacy. And therefore, you need a number, or basically you need quite a few numbers, but each of those numbers must represent your legacy in some way. So how this works, first you figure out the metrics. For example, if part of your legacy removal project is to replace all the legacy templates with tweak templates, then metric is fairly easy. Just a number of tweak templates in the system should rise, and number of the legacy templates files in the system should at least remain the same, but should not rise anymore. So that's generally fine. But you would also have more difficult ones. For example, you want to prevent that anybody creates classes which are children of some legacy class that you want to get rid of. So this is more difficult. Then you add these metrics into CI pipeline and basically trigger it on any build and then publish results. That's the point. Both teams and everybody involved should be able at any point after they finish some unit of work know whether they are introducing legacy or the system is getting a bit better by each commit. So, and then you do that by pushing stats into Grafana and plot them. And then you set soft limits. Why soft? You are tempted at this point to just make the build fail if any of the metrics go into forbidden direction. But this can, in a waterfall situation, this can really this can potentially choke the development and add problems. So basically, what we did is whenever there was a undesired direction of the change of some metric, we would just sit and look at it and figure out if this is a problem or not. Okay, so obviously this part is a tricky one. So how do you measure a number of child classes of a particular class? So this is how we do. Rick is is open source static PHP analyzer, which was developed by Marian, who is actually part of the team that did the refactoring effort, because he figured that nothing on the market was good enough for what we needed. So yeah, meet Rick. So it's an open source. You can check it out. It really works for us. I mean, this is some kind of output it would out. But for example, we for example didn't want any more legacy controllers, and nobody should ever use this anymore in the project. So we could actually, by static analysis, find out how many of those there are. You started with a huge bash line, and it just gives you all kinds of stuff. You can ask Marian all about it. He's the guy sitting there. Okay, so and then you plot it. So these are the lines, and as lines never lie, this is something which tells us that we are getting in the right direction. So this is the number of child classes of our legacy controller. It's going down. It went down by the third. The point that I was making earlier, in the ideal world, by the end of the project, all these will be at 0. What we decided is, no, this will not get to 0. This would get to 0 eventually. But we figured out that the best way to actually achieve the goal is just make the conditions in which this can happen. And for example, this is a correlation that you would like to, which makes sense. For example, the number of legacy template files goes down, and at the same time, the number of tweak template files goes up. So this is what you expect. And so this gives you confidence that you are actually removing legacy from your system. Okay, so in order to stop creating new legacy, you first need to figure out, let's say, agree what's legacy. So in this case, we published the good practices document and make it very clear what's considered good practices. We deliberately didn't call it best practices because this usually starts flame wars about terms, and this works pretty fine. So stuff like, all service classes should be fully unit tested, no business logic should be added into any controller, and so on. And one aspect of it is that everybody is familiar with it and that everybody agrees with it or understands why something is there. So you should at least clear the rules, but you should also give clear explanation on why. So for example, if we want to all service classes that should be fully unit tested, that's because we want to do a refactoring effort. So unit tests are something which you can run very fast, and then therefore you will run them, and you'll be a happier person for the result of it. So this is why. And also add examples. Examples are like best thing ever for making somebody understand what's written there. Okay, and then as a next step, you get the system into state where adding new features do not include legacy, introduces very little of it. At this point, this becomes specific to our stuff, and we'll be talking some about Symfony stuff, but I'll try to keep it as technical free as possible. So first thing, and always the first thing, make sure that you can make small steps. If you are getting system to a better state, if the only way to get there is via big steps, you will never get there. Maybe you will do one or two, and then something more important will just jump in. So small steps is key. So there is some low-hanging fruit, which we were able to utilize very, very quickly and very efficiently. First, you introduce the dependency injection container, which in turn makes you write service, kind of pushes you towards service-oriented architecture. Then you add event. The cool thing is it's a black box. You just make sure that your kernel of your application, whatever it is, knows about it and you're set. Also, event dispatcher and event handling, that allows you to write services which know as little as possible about the outside world and get called in a proper way. And then what you can do at this point is you can start follow the Boy Scout rule in the main layer. And that's very important because Boy Scout rule is very, very, very important. So this is easy. It's a bit more hard is getting system into state where when you change existing stuff, you still don't introduce legacy. And first of all, you need to be able to take more steps. And here, this is harder. So one thing that we did, this worked for us. We installed Symfony alongside the app, and then fixed all the stuff that happened because directory structure, stuff like that. And then that was Symfony 3, and they introduced decorating the services in the container. And this was pretty much awesome, and so we decorated everything. So the idea was to do this. This is the original situation. We have domain code, which uses legacy application framework code, and then via it uses infrastructure. This is simplified, but basically that's it. And what we did is we kind of cut down the bottom half of our framework and replace it with a facade, with a really decorated Symfony. So all the actual work was being done by Symfony, and our application still thought it's talking to a legacy framework. So that was the approach that really, really worked and was being made able both by class aliases and especially by Symfony's ability to decorate its very, very easy decorate its services. We call it facade. There is internal battle going on whether this is a facade, whether this is a bridge, whether this is an adapter. I don't know. We call it a facade, but what it does really this. And at this point, this gives you really one additional very, very, very important feature. It means that your domain code can use Symfony. And at this point, you can add new features which are completely Symfony. So for new stuff, you produce zero legacy. And this also enables you, when you refactor something and move it from the legacy framework, you know that it will work because it was Symfony doing the work anyway. So you know that there won't be some weird quirks there. Okay, so yeah, not quite. There is one very, very important thing that was missing from this picture, and this is Doctrine. And this is usually or data layer, ORM. This is usually the most tough dependency to break, because pretty much it's throughout everything. So there was a security layer, but that was easy. Symfony has preferred way of doing it. You write your own provider and you're set. But Doctrine was not that easy. So we'll talk about this. Has a lot of code. We have all this code in a repo. We would open source it, but it doesn't make much sense because it's just for our framework, so it wouldn't be useful. But this is really cool code. So if anybody is interested, I'll be in the on Tricoder's booth there, so I can show you all the code that you want to see. This part is really clever. So what you need is for Doctrine to be able to handle your legacy objects, and for your legacy data layer to be able to fire Doctrine events. Why? Because you want to gradually refactor your entities. And to do so, you need to be able to just remove just a bit of logic from your God class, and Active Record kind of promotes that. In Active Record, quite a lot of time, it's really easy to add a lot of logic into your model, which doesn't belong there. So in order to refactor this in a serious way, you have to move bits into services, and then they call and so on. But it will never happen if you have to refactor an entire class. So therefore, you have to have a system where it can be both ways. It can be both things at the same time. You have your legacy entity, but some part of it, it's really handled, depends on Doctrine. And yeah, because otherwise you just won't be, ever will be refactored. So this is never mind. So what we did, we did a facade. We basically refactored or changed our legacy data handler, our Active Record one, to really just use Doctrine behind the scenes. So, and to do so, you have to write like a data mapper, and Doctrine just allows you to do that. This is a kind of feature which they have. So this is just something that translates from your however your metadata is constructed into something that Symfony understands, Doctrine understands. And at that point, you can save your objects, and they will fire all the events that they need to fire, and great stuff. But Doctrine will not call the template methods of the Active Record classes. So for that, we made a global event listener, which find out which cases where Doctrine is using our legacy entities, and then fired those, basically call those methods. So this was done in that way. And the final obstacle was loading, because it seemed it will be easy, but Symfony is doing hydration for you. And in the ORM way, it returns hydrated object, and the Active Record just hydrates itself. So that part was a bit tricky, because Doctrine documentation is really not clear on the subject. It required reverse engineering the unit of work, and it was kind of tricky, but it actually works, and there is a hydrator entity in the Doctrine that you can effectively use and pass this as a reference, and it works. So we did it to get rid of the last part of the really heavy dependency. Once you sever this dependency to ORM, then you can start changing your admin. Admin kind of binds all together, because it expects everything to be legacy and everything to be in a good old traditional way it was. So yeah, we did as a result, we open sourced two packages. One is JSON API bundle, and one other is UI for customizable UI for the admin. You can check it out, and yeah, we are actually using them, and yeah, we really like how they work. Okay, so for refactoring conclusions, you have to have risks when you are breaking dependencies because of the legacy. You will not probably won't get 100% compatibility. For example, Doctrine doesn't have before load, our legacy system does. So we just said, yeah, you have to deal with it. It says, okay, this is no longer supported, change it. Usually it's stuff which is rarely used anyway, so you are fine with it. And set realistic refactoring goals. You have to make them small, really small. Okay, so we saw that earlier. Okay, so on synchronizing teams. Basically, yeah, this we saw before, and the main risk that you are having is the risk of merge conflicts. Because if you can have terrible merge scenario where you're paralyzed for a week, and this in Scrum you will live, you live and learn, but in Waterfall you will not, because maybe this is just that last block that threw your schedule all off. So how do you do it? Pretty much the same way as in removing legacy. You write the merge policy document. Basically, you appoint merge officers, people who are really, whose sole responsibility is that merging succeeds, that it will work. Then merge often, obviously. And have everybody understand the merge policy. For example, their merge policy is there will be a merge officer. They will be rotated, and importantly, they will actually have time for this. So it's not some role of somebody who will make things work. No, actually, this is something that you plan, and make sure that that person has time. And if it has time and knows why it's doing it, then things get way better. And also, when you have those merge officers, they will naturally communicate and make sure that teams know what's other team working on, and that they don't work on the same things, and so on and so on. So, yeah, stuff like that. You will have to have very good standards and follow really strict rules about commit messages, and this only works if you have strong peer review process. But yeah, if you do, so the big question: did it work? Have we mitigated the risk of merge conflicts? Yeah, it did actually. When we did it right. So obviously, this is one iteration where we didn't do it right. So if when done right, it takes less than 1% of iteration resources. What we did here was when we did a change. Well, the yellow team did a change in which they changed a lot of files because they were changing the translation system. And then, for reasons because what could possibly go wrong, they also reformatted the files to be very, very nice and neat. And then there was like a gazillion merge conflicts. And of course, it was been done in such a way that it would take more time to really untangle all this. So the team had to go through those files once, one by one. And as you see, okay, so the yellow team did it. The yellow team paid the price, but still it was below 5%. So still that was pretty acceptable. And as in the next iteration, the blue team was just business as usual because yellow team was cleaning up to themselves, but still it was about 2%. So still they're fine. So this is a situation when, yeah, we did things we shouldn't have done. We should know better. And we had one more, which is not on the graph, and still it's below 4, where we broke our own rules and said, yeah, we will have 3 weeks before merge. What could go wrong? And one team changed to HTTPS in the meantime, and like 1 million files, and so on. So this is something, it shows when you break your own rules, the system kind of works because it has spikes. But otherwise, yeah, this is fine, actually. Okay, so what are the main lessons that we'll learn? So first, it's doable. And the way to go, in our opinion, is to really do it the way, don't go for zero legacy. We'll never get there because it's unattainable goal. It's really stopping entropy. You cannot really stop it. You can just manage it. So it is doable if you are doing the right scope. Facading was a lifesaver for us. Everything ended up to be a facade. And this works really well and allows you to have this, to be stuff like in both states at the same time. So this is very important because this allows you small steps. You need discipline, especially for synchronizing teams, because otherwise you can get in really messy situations. But you also need flexibility because it's refactoring and stuff is not completely, you don't know everything in advance. You have to adapt. You can do this without really, stringent code review. For example, in this scenario, there can be no commit on the master branch without merge request, and it has to be peer reviewed by at least one senior, something like that. And we have had the plus of having domain expert on the team who knew about the system, the refactoring system. The refactoring team had a guy from the product team who actually knew the system, and this helps a bunch. So this is basically it. So in the end, this is the main thing. It's doable. It actually works. So yeah, we don't have time for questions, but I will be outside. So if anybody wants to discuss this and see some code, yeah, I'll be there at Recorder booth. You will see me. Okay. Thank you.
Thanks to our speaker.